What we've got here is a nice logarithms question. It's going to bring into play our rules of logarithms and our laws for manipulating them, and also properties of logarithms and values associated with them. So part A is going to use these rules, going to look at all of our laws that we've bringing together. Part B is going to bring in ranges of values, but this can be investigated by looking at the graphs of logarithms. So it's important that we know this. Now for the first one, I want to evaluate log to the base 2 of 5 plus log to the base 2 of 1 over 40. Now one thing I need to do in order to be able to do that is remember that if I have log to the base a of x plus log to the base a of y, so both logarithms have the same base value, I can combine the two of them to a logarithm with the same base value, but multiply the elements together and have x times y. So if I have that, this log to the base 2 of 5 plus log to the base 2 of 1 over 40 can be written as log to the base 2 of 5 over 40, multiply the two of them together, which gives me log to the base 2 of an eighth. So that's me done my first step of simplifying. Now another thing I maybe want to ask myself is, can I get this down to just a single constant value and eliminate the logarithm itself? Now in order to do that, one law of logarithms that I want to remember is if I have log to the base a of a to the power of n, I can bring down the power and make that n times log to the base a of a. Now log to the base a of a is equal to 1, so it just becomes n. So if I can somehow write 1 over 8 in terms of 2 to the power of something, I can use this law here. Well, if we remember, 1 over 8, that's the equivalent of 8 to the power of negative 1. Now 8 we know is 2 cubed. So that's 2 cubed to the negative 1, which in this case gives me 2 to the negative 3. So if I take my logarithm and rewrite it, I'll get log to the base 2 of 2 to the power of negative 3. And if I then look at this law here that we wrote down and compare it with that, that's the same as log to the base a of a to the n, where the a's are 2 and the n is negative 3, which means I can simplify that to the value of negative 3. Now this is something, if this were a calculator paper, we'd be able to check, but because these are nice values that all match up in terms of base values, we're able to just leave it like that, because this would fall into the non-calculator category. Now if we look at part B, it wants me to think about a being a real number and log to the base 8 being negative, stating the range of possible values for a. Now, easy way to think about this one is think back to how the graph of a logarithm looks. If we remember back to the graphs of logarithms, we know that the logarithmic graph always looks like this. Now remember, logs are the inverse of exponentials. So the graph will always look like this. It'll always cut here at the value of 1, and that's how it'll look every single time. Now a key thing to notice is that between 1 and 0, it gets closer and closer to the y-axis, but never physically crosses it, because we can never take log of a negative value. So we can never do, for example, log to the base 8 of negative 6. Calculators would give us an error for that one. However, the key thing we want to know from the question is when log to the base 8 of a is negative. So if I imagine that this here's the graph, log to the base 8 of a, it wants to know when it's negative. So basically it wants to know everything that will fall below this part here, because anything less than the 1 will be a negative value. Now it's important to remember that it's anything less than 1 because it's log to the base a being negative. If a was 1, it would fall on the x-axis, so the value would be 0. So for this one here, what we're able to do is we're able to say that a is less than 1, but go back to what I said a moment ago, where I said it gets closer and closer to the y-axis, but never physically touches it or crosses it. It also has to be bigger than 0. So for it to be negative, the value has to lie somewhere between 0 and 1. So 0 less than a, less than 1, that there's the range of possible values for a. where we want log to the base a to be negative. So there you go, 2 logarithm-based questions for us to be able to work with, working with our laws of logarithms. Marks will come into play here and here for using our laws to simplify, and then this one here will give us a mark for knowing and remembering our graphs of logarithms and ranges of values, where they're valid and where they satisfy our condition. So there you go, remembering those bits of information, remembering those laws in the graphs, easy peasy, lemon squeezy.